Okay, so this example will demonstrate the use of your polygon method. But first, let us use your component method. In order to compare, what method would be share? Component method. Okay, so by component method, you would break down each forces into its equivalent F and X component. But we will have their summation of F of X and the summation of your F of Y. Okay, so first, let us break down your 250 Newton. 250 Newton or your F1, and then we'll break down your F2 and F3 and F4. Okay, so we have 250 Newton. Take note that the given are its coordinates. The magnitude of your X and Y ratio is already given by the units 3, 4, and 5. So therefore, we will have 250. So negative because it is going to the left. Negative 250 cosine theta. So considering your theta at the x direction or the x-axis, so therefore we'll have negative 250 cosine theta. So we'll have our theta. Okay, this is your 250, and then we have our 3, 4, and 5. Take note our cosine theta will be equal to adjacent over hypotenuse, which is equal to 4 over 5. So you'll have negative 250 multiplied by 4 fifth. Next is your F2. So the x component of your F2, let's say this is equal to 400 Newton. This is the magnitude of your F2, right? So at 400 Newton, so we'll get the x component. So 400 angle of 30 degrees. So 400 positive. It is going to the right. 400 cosine 30. So 400 cosine 30, it is equal to 346.41. Okay. Or I will not break down the 400 cosine 30 yet. And then your F3, which is equal to 300 Newton. So 300 Newton, 300 angle of 0 because it's going to the right. But if it is going to the left, it will be 180. But since the direction is going to the right, it is angle of 0. Okay, so cosine 0. So getting the sum of this one, of these forces, okay, so therefore we will have a value equal to your summation of x, f of x is equal to negative 250 times 4 over 5 plus 400 cosine 400 cosine 30 plus 300 cosine 0, which is just 300. So we'll have a value equal to 446 Newton. Okay, 446.41 Newton. 0.41 Newton. This is your summation of f of x. Okay, and at your y, so getting the summation of your y, so we have f of y 250 sine theta. Take note that it is positive because it is going up. The force is going up, so therefore the component is positive. So we have 250 sine theta. But what is our sine theta? So let us go back to this SOHCAHTOA. So sine theta is equal to opposite over hypotenuse, wherein we have 3/5. Okay, so 250 positive, 250 multiplied by 3 over 5 plus our 400, the component of our sine of our 400 sine component. So 400 or your y component, 400 sine 30 plus 300 sine 0, which is basically equal to 0. There is no y component at 300 Newton. Okay? So, 0 yan. So, therefore, our summation of f of x will be equal to 250 sine times 3 over 5 positive plus 400 sine 30 is equal to 350 Newton. Solving for the magnitude, so Fm, or the magnitude of your force, of your resultant force, will have a value equal to summation of f of x squared plus summation of f of y squared. So we have square root of 446.41 squared plus 350 squared. Okay? So we'll have a value equal to square root of 446.41 squared plus 350 squared. So 567.258 newtons. That is the magnitude of your force. So solving for this one, we will have theta. So the theta will be equal to, so if we would rewrite these forces into their x and y component, therefore I may say that we'll have a value equal to a positive theta, right? Okay, so this is my y component, which is 350 Newton, summation of f of y. And this is my x component, summation of f of x. So this is 446.41 Newton. Oh, sorry. This is a positive direction. Okay, so this must be here. Summation of f of x. This is 446.41 newtons. So, by parallelogram law, we can get the value of its resultant on the positive x and y axis, which is particularly at quadrant 1. So, this must be your theta. Okay, your theta will be equal to, so you may use your arc tan, arc tan, but particularly, yes, let us use your tangent theta. So, arc tan, or your tan inverse opposite over adjacent, your opposite would be 350 Newton. So, take note that this is the Fm, or the magnitude of the resultant force, which is equal to 567.258 newtons. And then our theta will be equal to arc tan, or tan inverse opposite, which is 350 all over 446.41. So we'll have a value equal to shift tan 350 all over 446.41. The value must be equal to 38.1 degrees. Okay, that is using our component method. How about if we would use, syempre since it is already more than 2, pwede natin siyang i-parallelogram, but the better way will be your polygon method. But as you go on to the process, you can see that you are still using the parallelogram law because of the different triangles that you would create in order to solve the problem. So, using our graphical method. Okay, so how would we solve for the graphical method? Always remember the tip to toe rule. Okay, so you should not alter the direction of the force, but you should always connect the force on the tip of the other and the toe of the other. Okay, so let's say my initial force will be the 300 Newton. Okay, 300 Newton. So this will be my initial or my point, initial point. So let's say this will be 300 Newton. Just going to the right. And then I will project my 400 Newton here. Okay, projecting my 400 Newton on the tip of my 300 Newton. So the toe of my 400 Newton will be at the tip of my 300 Newton. So this would be a 300 Newton, 400 Newton. So never forget the angle. This is 30 degrees. Okay. And then next is my 250 Newton. So the tip of my 400 Newton must be connected to the toe of my 250 Newton without altering its direction. So therefore, this will be my 250 Newton. $250 Newton. Okay. So we have the angle, which is according to the problem, it is 3, 4, 5. Okay. So in order for me to not confuse myself, I may solve this angle, which is basically equal to shift tan. Tangent theta is equal to 3, 4, or theta is equal to arctan 3, 4, or tan inverse 3 over 4. So shift tan 3 over 4, we have 36.86 degrees. 36.86 degrees. Okay? What would be our next solution? Since you are using your polygon method, polygon must be a closed figure, right? So in order to get the value of your resultant force, you would use the resultant force to sum or to get the sum of the vectors. So from initial point to Pi to my Pf to my final point, my vector would be used to, or the resultant vector will be used to close the whole figure. Okay, yan. That would be my figure for my polygon method. So now we will solve for your FR or your FM. So how will we do this? Okay, very easy, right? Very easy. So first thing to do is I will get the value of this force. Like I have said, so FR, if you have three forces, F1 plus F2 plus F3, you must consider to add first forces first before adding the third force. So therefore, I will consider to add my 250 Newton, which is basically our F3 of F1, and my 400 Newton is basically my F2. Okay, so by parallelogram law, we will add this one by simply expressing it into a one resultant force. So let's say this will be my F1 plus F2. Let F1 plus F2 be equal to FR1. Okay, so I will project my initial position to the yan. Okay, this will be our FR1. So how to solve for FR1? It is just a matter of analysis of its graphical its graphical characteristics, particularly triangle. So take that this theta or this angle is already equal to 36.86, and this angle is 30 degrees. So if I will project it up, this angle is 90 degrees perpendicular. So therefore, I may say that this angle, let's say theta 2, will be equal to 30 less 90. This will be the complement of your 30 degrees, so therefore this is 60 degrees. Okay? So if this is 60 degrees, I may say that this angle is 30 degrees. Right? That angle will be 30 degrees. So in order to get for my FR1 using our cosine law, I must get the value of this angle, right? Which is, let's say, angle beta. So I will say that that would be my angle beta. Therefore, solving for beta, will have a value equal to your beta is equal to 30 degrees plus 36.86 degrees. So we'll have a beta equal to 66.86 degrees, right? 66.86 degrees. That is my beta. Now, after solving for my beta, I can easily solve for my FR1, right? Use solving for FR1, we would use our, of course, your cosine law. Using cosine law, the two adjacent forces that would be used is your F1 and F2, okay? So therefore, we will have a value equal to your FR1 squared, okay? FR1 squared is equal to F1 squared plus F2 squared minus 2F1 multiplied by F2 cosine beta, right? So, getting the square root of your FR1, so FR1 is equal to square root of our F1, which is basically equal to, our F1 is equal to 250 newtons, and our F2 will be equal to 400 newtons, okay? 250 newtons squared plus our 400 newton squared minus 2 multiplied by 250 multiplied by 400 cosine beta, which is 66.86 degrees. Okay? So therefore, we will have a value equal to square root of 250 squared plus 400 squared less 2 times 250 times 400 times cosine 66.86 degrees. So the value of this first one is equal to 379.347 or 35 Newton. 347 or 35 Newton. So that is our FR1. So as I have said, the thetas and the angles may vary on to your rounding of number. Okay. After solving for your FR1, let us solve for your FR. By how? So take note that we have already our FR1, which is equal to F1 and F2. So therefore, I may say that my FR will be equal to FR1 plus F3. So FR1 plus F3, we will get your resultant force, right? F3. So after solving that one, we will go or solve for your FR3. But how will we solve it? Will we solve it immediately? Not yet. Basically because we will solve more for an angle, particularly any of this angle. So let's say we'll have a value of your alpha 1, okay, alpha 1, theta 1, theta 1, yes, phi 1, okay. let us analyze what will be the best angle to solve in order to get for your FR. Okay? The best angle to solve will always be the angle opposite to your FR. Right? In order to directly solve for your FR. But how? So take note that this is 30 degrees. Should I assume that this is 90 degrees? No. This would be the angle of your theta, let's say alpha 2, or another, let's say angle alpha. Alpha 2 na lang, ulit. Sige. So alpha 2. Okay? So how will you solve for alpha 2? Take note that this will not be assumed to be 90 degrees. Never assume that your resultant force is 90 degrees. So the best thing to do is that we will solve for your FR or your alpha 2 by sine law. Solving for alpha 2, solving for alpha 2. Your alpha 2 can be solved by, so take note that alpha 2, the opposite force is your 250 Newton. So using sine law, so we have our alpha 2, which is 250 over sine alpha 2, 250 all over sine alpha 2, which is equal to your FR1 all over sine beta, right? Sine beta, because your FR1 has its opposite angle beta over sine beta. Okay? So solving for the value of your alpha 2, so we'll have 250 sine beta divided by FR1 is equal to your sine alpha 2. So getting arc sine or your sine inverse, sine raised to negative 1, 250 sine beta all over FR1, which is equal to alpha 2. Therefore, our alpha 2 will be equal to sine raised to negative 1, 250 sine beta is equal to, your beta is equal to 66.86 degrees divided by FR1, which is equal to 379.35 degrees. 379.35 Newton. So therefore, our alpha 2 will be equal to shift sine 250 sine 66.86 divided by 379.35. So our alpha 2 will basically equal to 37.3 degrees. 37.3 degrees. Okay. How will we solve for our alpha 1? So solving for alpha 1, take note that this angle is equal to 180 degrees. Okay. So solving for alpha 1, solving for alpha 1, we all know that your alpha 1 will be equal to 180 degrees less alpha 2 less 30 degrees. Right? Basically, we have 180 degrees and our alpha 2 is equal to 37.3 degrees. 37.3 degrees less 30 degrees. So we have our alpha 1 will be equal to 180 less 37.3 less 30. So we will be equal to 112.7 degrees. That is our alpha 1. Okay. after knowing that alpha 1, so therefore we will solve for your FR. So going back to your cosine law, so our FR will be equal to the square root of FR1 squared plus F3 squared less 2 FR1 multiplied by F3 cosine alpha 1. Okay? So, let us change the color. So, we'll have square root of our FR1 is equal to 379.35 Newton squared. So, tanggalin muna natin yung Newton. Pwede na natin i-factor out yan. 350 Newton plus our F3, which is equal to, our F3 is equal to 300 Newton plus 300 squared less 2 multiplied by 379 multiplied by 300 cosine alpha 1, which is 112.7. Okay? So, we will have a value of your FR equal to square root of 379.35 squared plus 300 squared plus 2 times 300 times 379.35 cosine 112.7. We will have a value equal to 567.22 newtons. That is our FR. Okay? So, compare it to the value of our FM or the magnitude of our FM. They are actually the same. So, the only difference will be the computations of values or the significant figures when rounding the numbers in solving for the particular answer. So, how will you solve for your theta? Okay, so how will you solve for this theta 1? Okay, we can solve it directly, right, by sine law. So, we'll have our FR1 solving for theta. Solving for theta. So, how will we solve for theta? Take note that your theta, its opposite magnitude is your FR1, and your FR has opposite magnitude of alpha 2, right? Okay. So, we'll have FR1. FR1 all over sine theta, which is unknown, which is equal to our FR all over sine alpha. Okay? So, our FR1, which is equal to, FR1 is equal to 379.35, 379.35 sine theta is equal to our FR or the total magnitude, which is equal to 567.22 all over. So, take note that it is Newton, right? We factored out it earlier. So, Newton, and your sine alpha is 112.7 degrees. Okay? So, solving for your theta, we'll have sine inverse or arc sine 379.35 sine 112.67 divided by 567.22. Okay? So, our sine theta will be equal to, our theta will be equal to sine 379.35 sine 112.67 divided by 567.22. We will have a value of 38.1 degrees. 38.1 degrees. So, as you can see, we have a similar answer. So in conclusion, therefore, our FR will be equal to 567.58 newtons. Okay, 567.5 newtons. Let's say 567.568 newton, angle of 38.1 degrees northeast, or at positive x-axis. Okay, so this will be our solution for this problem. I hope you have enjoyed the use of your polygon method in solving the problem. Okay, so also try to use more than 3 forces. If you could use the polygon method, of course yes, but take note that you would break it down into forces. You will use the commutative law of addition of vectors. Okay, so therefore, thank you.